Hi guys, welcome to Gyrate, and I am Arihant. So, as you guys know, that recently we had Chandrayaan 3 mission by ISRO, and I'm really proud for the mission. Being an Indian, being a space enthusiast, being a rocketeer, I'm like so excited to see that it happened. It's like so good, and I'm so happy and motivated after seeing that. And now this Aditya L1. So after seeing Chandrayaan, I was like so much mad about it. Like I was already so much into that thing, and now after it got successful, I was like, no, now I want to get there. Now I want to see. I want to be in that field. I want to just enjoy. So I thought, why not? Let's work on it and make something of our own. So I decided that here at Gyrate, we'll develop some rockets and we'll develop some satellites. We'll start from model, and God knows, who knows, we might be there someday. We might have something of our own. So let's start with it. And I'll be starting a series and in which I'll be making a model rocket. So let's dive into it. We'll be making a full-fledged model rocket which will be flying, and here we'll be starting with it from like initially the planning and all, and buying all the components and then assembling, uh, testing. So basically what I am planning is that I'll be designing everything and I'll be manufacturing everything. So I'll be ordering the parts for the flight computer. It will be thrust vector controlled, and we'll be using solid motor. So first, I thought that I should order some motors for this project, but when I saw online, so India is not having a very good market about like these things. Like they're very less power. Like C or D are like the max you're getting here easily. Obviously, you can get more, but like you need to do a lot of hard work for that. So I thought that why not I design my own solid motor rocket. So first we'll be designing a solid motor. So for that, initially I'm working with what I'm thinking is making a sugar motor. So sugar motor is nothing but potassium nitrate, and we'll be using sucrose, which is the table sugar. So we'll be starting with table sugar and sucrose, because initially I don't want to get involved with APCP because I am a noob in this and I don't want to mess up. So that's why I have ordered the chemicals sucrose and KNO3, and I'll be mixing them. So we'll talk about that further in different like the videos in which I'll be actually talking about the fuel and the motor building. So, but that's the outline of it, that we'll be doing that. Also, the flight computer initially, which I am using, is like it is one of my own designs, and I have named it as Quark. So Quark is nothing but it is the smallest thing which is known to humans. It is even smaller than atoms. So as it is my first creation, so I named it as Quark. I'll show you the layout and the parts used in Quark. So I designed the PCB and all for it, but after designing, I thought that before using the PCBs, before getting them printed, I should maybe get a proto board, and I should assemble up everything, and um, then I'll like a PCB manufactured and then solder everything on the PCB, because it will be a classic engineering failure if the PCB fails itself. So first, the initial step, the first step which I'm thinking of doing is I'll order proto boards, and I'll order all the components. So as it is my first computer, so I'm thinking of using Arduino Nano, because it will fit in small place, and some sensors. So I'm thinking currently of 2 or 3 sensors, which I'll tell you about in a while, and mainly we'll talk about them in the avionics video when we'll be designing the avionics. But before that, you'll get to know about them because of the part ordering. So we'll be ordering everything, and initially I thought of going and buying everything, but due to some like time constraints and all, I thought let's order everything now from these local vendors, and then let's see if everything's good. Then right now I'll work with them for future videos, and for future projects I might use some particular like some of the particular people I know from whom I'll be buying the stuff. So what do we need in a rocket? How does a rocket basically control itself if we talk from avionics point of view? So we need a processor or a computing unit which computes everything. We need telemetry. We need the sensors to know where it is going, where is it is accelerated, what's its current orientation, at what altitude it is, and also you can get the temperature if you want the temperature around it. So first, so this is like the most basic. Like avionics is divided into two parts: the ground station and the flight computer. So the ground station needs to have a system through which it can communicate to the rocket, so that we get to know, is it following the required trajectory, what all, which state is it right now in, is everything working. So all those things we'll get to know through telemetry. So we'll be designing, initially we'll be using an antenna system of two antennas. It's having a range of about 1100 meters. But after that, I'll be designing a parabolic antenna of my own, which I'll be using so that we can increase the range to that same system. Because like I'm using an approach in which I want to buy the minimum resources initially, like the least required, the cheapest resources, exploiting them, using them to the max. After that, shifting to new resources, so that more and more use can be done from the required resources. Because as you can see, the rocketry, like model rocketry, is also not like a cheap thing. It requires money. It's a pit hole of money. So I want to use my resources wisely. So this project, the initial first project, I would like to just learn how everything works, how we can do telemetry, how we can control, how we can thrust vector, how we are designing a motor, how we are analyzing the pressure and all. I'll be using some CADs to design the motor. Most probably I'll be using open rocket for designing and open motor for like simulation of the fuel which I'm using. So I'm using NACA's mix, so it's KNSU. Popularly, I guess KNSU is the name which is being used for it. So that's my plan about it, at like how I'm going to approach it. I'm also thinking of making a recovery system so that we can, you know, get our rocket back. I don't want to waste all that money in just one rocket, because now world is shifting on reusable rockets. So I don't want everything that I am doing is just one flight and everything's done. I want to learn as much as possible from that every rocket. So that's about it. I'll be now talking about how we can how I'm going to go through it. So firstly, we'll order the parts, including the Arduino Nanos. Two Nanos we'll be using. So Arduino Nanos we'll be ordering. We'll be ordering the power supply unit. Like it's to regulate the voltage. We need a lithium-ion battery. We need two sensors, BMP 280, Ggyrate 521. I'm not saying these like these things on my own. I've researched already that I know I need to use all these components. So we'll be using these. After that, what do we need? We need resistors. We need capacitors of particular values which I've already calculated. We need a RF module so that we can communicate with the rocket and the ground station to get the telemetry. I thought of starting with Arduino because Arduino has a good base. Everything's just like you have libraries and all. You can easily work with Arduino. So that's why I'm working with Arduino. And now moving to the propulsion. So for the propulsion, we'll be using, as I told you, I'll be using KNO3 and sucrose. So that is there. And next thing, we need to understand, like we need to calculate how much pressure we'll be facing there. According to that, we need to use um, the liner and the body of the rocket of the the motor. So initially, I'm thinking of just testing the fuel by burning around 50 grams to 100 grams of fuel in a CPVC pipe, like basically designing a small grain, so that we can, like, it's just like POC, proof of concept, so that we can understand how it's going to be, how it's going to work, just to make a better understanding, or better conceptual understanding. Then after that, when I understand everything that's going on there, after that I'll be doing some static tests, some hydrostatic pressure test of the body of the engine, so that I know that the amount of pressure which I'm going to put on it, it's going to handle that. It's not going to explode. And obviously, we are not using gas. We are using a water for the hydrostatic test, because gases are compressible. And if you know that, if you compress something, when it bursts, it expands. And I think I don't need to tell that what will happen if a gas at 1500 psi expands. That's where we'll be using water, because water is not fully, but theoretically it's incompressible. So we'll be using that as as to check the pressure, how much it can handle, so that if it, even if it like breaks, it doesn't harm anyone anywhere. So that's how we'll be going with the engine part, because after the designing and all in open rocket and all the testing and all, after designing the engine, getting it in hand, we'll be putting everything together. So after propulsion part is done, like I'll be working in parallel with propulsion and avionics. So but after propulsion we'll be focusing on avionics, so we'll be soldering everything on the proto board, and we'll be working with everything according to our needs, whatever is required with it. And then we'll be going to the recovery part. So for recovery, either I'll make or I'll buy a parachute. It depends, it totally depends at that time, that whatever I'll do. For recovery, either I'll buy, most probably I'll be building it, because I don't have much experience with parachutes right now. So first I'll learn, and then I don't know what I'll do with that parachute part, but it will be there at the time of launch. So I'll whatever I'll be doing, I'll be explaining it through through this series, that yeah, this is what I'm doing. So that's how we'll be going with recovery, aerodynamics, and all. I'll be working, and I'll be giving you some sneak peeks about how we are designing the aerodynamics and the body of the rocket here. So most probably we'll be using a class E motor. So let's see how like exactly which motor will be finally be commissioned. But I'll be designing multiple sizes and multiple types, so that like the core type also I'll change, and I'll be using. Also, I thought of making it more and more like budget friendly. So I thought, what about I'll be mixing multiple types of fuels, as in not just single type of one this fuel I'll be using. I'm thinking of making and mixing, like first different qualities of fuel basically. So laboratory grade stuff will be used for laboratory testing. I'll be using the different grade of chemicals also, so that I can understand what's the relationship between the quality and the performance of the rocket motor. So yeah, that's the amount of plan what I'm doing with this thing, this the planning stuff. So now let's see what all I have added to the cart, what all things I'm buying, so that I can build this rocket up. So firstly, let's see the design on which I'm working. So here we are having a Arduino board in center, and this is the 7805T. So this is a 12 volt to 5 volt converter which we are using. This will be converting the voltage from 12 volt to 5 volt, because our most of our sensors, servos, and the microprocessor itself, microcontroller itself, would be working on 5 volts. We'll be using this, and 12 volts will be used by the pyro charges. Pyro. So what are pyro charges? Pyro charges can be like pyro points on a avionics computer are used for two purposes: for deploying the payload or for deploying the parachutes. They can also be used for deploying the landing legs, which are being used in Falcon 9, Falcon Heavy, and all. So it basically, you understood what I'm saying. That is used for that. Now we are using the 7805T. It's like it looks like a N-channel MOSFET, but it is used for power conversion. This volt to drop the voltage regulator. You can write on Adafruit's website 5 volt voltage regulator. You'll get this. Then we are using some terminal blocks to give in 12 volts and to connect everything up. We are having two terminal blocks for these. These are the pyro blocks. So these are here. We are using two N-channel MOSFETs to transfer that high 12 volt voltage to the pyros. The signal, the input signal of the N-channel MOSFET is given by the Arduino board, which is here on the 11th pin and the 12th pin, which I've connected according to the digital pins and the analog pins. I've selected which pins I need to use for what. So this is the basic basic like the stuff which is going on here. We are having a LED because a computer is nothing without LED and a buzzer. So we are having a buzzer and LED. Like it is a thing. It's a theoretical thing. It's like it should be there. I don't know the need, importance. I'm not even discussing that. It should be there because a computer with lights look good. It's just about the fact it looks good. So I need that. So that is there. Then we have this MPU system Ggyrate, which is having an accelerometer and gyroscope inside it. For future, I'm planning of designing like full board myself, like not using Arduino and all. But right now we're going with this. Then we have a BMP 280, which is the barometer for getting the height. If you have studied science in your high school, then most probably you would be knowing how we can get height from pressure. But if you have not studied, then it's just a simple mathematical equation from which, if you know the density, you know the value of g, you'll get the height according to pressure. It's not super accurate, but it's easier than setting up a radar at this point of time and this budget. So that's why we are using BMP 280. So actually, in this flight computer, I did not thought of designing a telemetry because it was made for different purpose. It was made for just ground testing, but now I'm thinking of using it furthermore. As I said, I want to exploit things to the max. So I haven't added in this design, but I'm also using RF module, which will be integrated to this to the like the there's it is working on serial communication. So we'll be connecting the serial communication points of Arduino Nano to that. So yeah, that's about the design, and you can see the PCB also here in this. I've designed the PCB already. So that's how the PCB looks, and let's see my cart about whatever I have added right now. So yeah, this is the card you can see, and as you can see, I ordered everything to the like sticking to the budget. I'm not going with high end stuff and all. I just want it to work with minimum budget because I want to see on how low budget you can just make something fly to a height of 1 kilometer, 2 kilometer, 3 kilometers, which is around 9,000 to 10,000 feet if you go by 3 kilometers. So firstly, I've ordered some tricolor LEDs as I showed in design. So this is having 20 pieces because they are sold like that. You cannot get one LED. These are the pins which I'll be using, two terminal pins. This is the voltage regulator I was talking about. It's the voltage regulator. I told you it looks like a N channel or P channel MOSFET, basically like a MOSFET. This is it. These are the capacitors. This is the BMP 280. So it's a barometer. Basically, it's a barometer. This is the GY521, the MPU which we'll be using, MPU 6050. Actually, it's the IC MPU 6050 which is embedded on this board. Here we are using the antenna system I told you already. So it's quite good. Like I've seen it on some projects. Some of my friends have used it. It's actually good. This is the 3 terminal point. Actually, I thought of using these for the servos because servo needs three cables. So this would be used for two servos for thrust vectoring in X and Y direction. So we'll be thrust vectoring like the yaw and the pitch axis. The roll will be I'm not sure for the roll right now because I might use a thrust vector control a reaction wheel to control the roll axis, or I might not. It depends on like how it performs first. Like initially I just want to see how it performs on a basic stand, like basically how everything goes, how I engineer everything. It depends on that. So I'll see that. And these are the servos which I'll be using, and these are the MOSFETs which we'll be using for firing the pyros. This is the buzzer, and this is the heart of the system. Finally the Arduino. So two Arduinos I'm using here for ground station and for the final flight computer. This is it, and actually I could not get everything from one seller, so I thought of getting some stuff from different sellers. So this is here. So this is the like 1 microfarad capacitors. These are the resistors which I require. I'll give the values later what all we are using. This is more capacitors which I'm using. This is some basic wire to use on proto boards. because we're using proto board. We are not using a PCB. So we need this. This is the lithium polymer battery which I'll be using. It's a 1200 mAh battery which is giving 12 volts, 11.1 I guess on output. This is it. And these are the proto boards which I'll be using finally for soldering up everything and wiring up everything so that we get a basic flight computer in our hands. So this is the stuff which I'll be using in here. So yeah, that's about it about the electronics part. Obviously, not to tell. I'll be showing the chemicals and all while mixing, but I won't. I'm only showing the packing and all because it's not necessary to see which basically which supplier and all I'm using. So that's like different story. So we'll be just using these, and I'll show you how to mix everything up, how to get everything started, and how to take your rocket there. It's my first project of like this thing, but I'm actually quite excited about it, and I hope it works. It will work because why will it work? Because I am built different, and I'll build it to work. So it will work finally, and let's see how everything goes. And yeah, that's it. So this is the intro video and basic design and all of our system, and you join me for the assembling, designing, planning, everything which I said right now in the further videos. And I hope you guys have fun and have happy building, and you have good time in engineering stuff and all. So let's go. Jai Hind.